in this particular model, we are going to see the conversion of PDA, that is Pushdown Automata, into a context-free grammar. So, you know the tuples for PDA. The PDA tuples are like Q, that is set of state, sigma, set of input alphabet, gamma, set of tape symbol, delta, transition, Q naught is the initial state, Z naught is your stack symbol at the bottom, F is the set of final state. So we are going to mathematically converted these PDA tuple into a tuple of VTPS. What is VTPS? That's a grammar's tuple. V for set of vocabulary, T for set of terminal, P for set of production, and S is your start grammar. So we are going to convert the PDA into the grammar. So what is the equivalent to it? So let's see the construction. So actually, like this table will help you to understand more. So for the conversion, actually you need to follow these three golden rules. Okay, for a start grammar, so obviously by default S is your start grammar. So S gives you have to make this tuple in such a way that if Q naught is your initial state and Z naught is your bottom stack symbol, always have Q naught Z naught with the combination of what are all the states the problem has. So that will be your start symbol. Second golden rule is with respect to push and pop. So for a pop, let us see for a pop transaction. So for a pushdown automata, for a pop transaction, the rules will look like this. So that is, for example, if I am in a Q state and if my input symbol is A and my top of the stack is Y, means if I want to pop A means then this will be going for another state R, and for pop we will be using epsilon. So if this was the mathematical formation for our PDA, the equivalent grammar will look like, just write this Q over here. So just write this Q over here and this Y over here and R over here. Okay, so it is the state, then stack symbol, then another state, and finally this A will be your production over here. So likewise you just equate the grammar accordingly. So what are all the pop transaction you have in your problem, you just convert likewise as a grammar. So now comes the push. So for a push transaction, usually for a Pushdown automata, PDA is represent that if you are in a Q state and if my input is A and my top of the stack is Y, means then I will be going to some other state and either I will be pushing the element. So it could be a one element, but basically for a basic PDA we will be pushing only one element. So it could be a number of element like mathematically. So if this is a state, then how you have to represent this? Write the Q over here, Y over here, same, but here instead of R, likewise here we will be writing all the possibilities of Y, that is Q. That is, for example, if PDA has two states, then you have to state Q0 and Q1, likewise, and so on. And how to write the RHS? Here the symbol A, that is whatever the symbol input is, and we need to write the sequence accordingly. That keep in mind that the beginning of the sequence should be the start state, whatever the state given in your transaction, and the end of the state should be the state which is equivalent to this one. So this you should remember. And how to arrange these Q states and all, it is like a chain. For example, if you write Q1 here, so same Q1 here. If you write Q2 here, same Q2 here, and likewise. Then what are all the symbols you have, you just include as a sandwich between these two states. I know it is very fuzzy. Once we solve the problem, you can able to understand this. So let us take a problem over here. Okay, so this is the problem over here. So they have given that these are all the our tuples. So this is our Q, that is your set of states. So we have only two states, and this is my sigma. So sigma is the input, so we have two input, and this is my gamma. So two stacked symbols are there, X and Z naught, and delta. So these are all of my deltas, and Q0 is my initial state, Z0 is a stack symbol, and they haven't specified any final state, which is very much fine. So from this state itself, you can see that like we have around like you see we have around, these are like pop symbols, pop transaction, and these are all like push transaction. So we need to follow, like apply that rule over here and the rule over here. Okay, so now first, so we for an grammar, what are all the tuple? It is VTPS, right? So first we need to write what is V, what is P, what is P and S. So here first comes the terminal. Already from the problem itself we know what are all the input, so simply you can write what are all the terminals. And then comes the V. V actually will be having both the terminals and non-terminals likewise. So here actually V means vocabulary, so that could be the combinations of all. So how to write this? So this is my start grammar, yes. And how to write this these states? It's very simple. You know very well, I have like two state, Q0 and Q1, and I have these two like tape symbol and so on. So you simply like a probability. See here, Q0 x Q0, Q0 x Q1. Similarly, in the place of x, you put Z0, Q0 Z0 Q0, Q0 Z0 Q1. So like a probability, you just write all the combinations over here. Okay, so that is my vocabulary. Fine. Now let's start with how to find S. Okay, so this is the rule which we have seen already. I have colored accordingly. See here, this yellow color comes here, this purple color comes here, and this blue goes there, and this green comes here. To understanding, I colored it accordingly so that you will remember how this got fitted. Okay, so let's start with the start symbol. So in the as per the rule, they have said that S is equal to Q0 Z0 and Qy. So in this problem we have only two states. So it could be Q0 Z0 Q0 or Q0 Z0 Q1. So only we have two states. So I applied the rule 1. Fine. Then comes my pop. I take all my pop symbols. So first one pop is this is my transaction as per in the problem. Here you can see that I just shifted over here. Q1 here, X here, Q1 here gives this one. Likewise, similarly Q0 X Q1 gives 1. Similarly Q1 X, this Q1 gives this epsilon. Similarly Q1 Z0, this Q1 gives this epsilon. So don't confuse over there. This only it will be there in the right hand side of my grammar. So writing the like a equivalent grammar for a pop transaction is very easy. So we have created over here. Okay, so here I have written at non-generative. Wait, I will tell you what it is. Okay, next for push symbol. So we have two push transaction. So Q00 Z0 and Q gives that so on. So this was my push transaction. So here they are pushing like that Z0 is already there. On the top there is X. Okay, there are two symbols over here. Fine. So as per the theorem, how we will write this Q over here, this Y over here, and this should be like, it could be number of states. So similarly Q over here, this Z0 over here. So this could be the number of states. So I have like two different states. So it should be Q0 and there should be another production with Q1. Fine. So how to fill this? So here A. So here my A is 0. So I have written 0. Always start with R. That is, we need to start only with Q0. You can see here, I start with Q0. Here I start with Q0. Fine. Then how I filled this? So I need to use two symbols. So X. So as it start with Q0. Here let us end with Q0. So why I am choosing Q0? Why it can't be Q1? Yeah, that also I have written a production over here. Okay, so it is like a probability. So it could be Q0 or it could be Q1 also. So first we will deal with Q0. So Q0, if it is Q0 like a chain reaction, here should also Q0. Then insert the symbol Z0. After Z0 I don't have any symbol, right? So I need to end this. For ending this, what was the rule? Here QK and this QK should be equivalent. So here this one and this one is equivalent. So I got my first transaction. I told So it should be Q0 or it could be Q1. So if it is Q1, so the nearby could be Q1, Z0, that's it, my transaction got over. So it should be ended with Q0, so I ended with Q0. This is one way. Next, for this one, again 0 over here, then Q0 over here. This Q0 should be the same, right? Then the symbol X, as Q0, it could be Q0 or it could be Q1. Then Q0 with Q0. Then that's it, my symbol got over, but it has to be end with what? Q1. So I ended with Q1. Similarly, same thing, 0, Q0X. Instead of Q0, here I am having Q1. Okay. Then if it is Q1, this is also Q1. Then next symbol, that's it, over. So I end with Q1. I know it is very difficult to understand, but it is literally a sequence. There is no like it is not like a very toughest max. It is only writing the things in a sequence. Okay. Similarly, take the next production. So here also Q0 here, X here. So here it could be Q0 and it should be Q1. What symbol I have to write here? Here the symbol is 0. So write the symbol is 0. Always start with whatever transaction I am having here. So start Q0. Then the symbol is XX, only two symbol. So X, same thing, Q0, Q0, X, and it has to end with Q0. So again in the place of Q0, I should put Q1 also. Q1, then if it is Q1, here also Q1 and Q0. Don't mind why I have cut it, because finally it has to be cut, so only it was there, okay. So we should write it first. Then similar way you write this. So if it is Q1 means same, Q0X, so it has to be end with Q1. Here also this instead of Q0, here Q1 and it end with Q1. So I have written all the transactions. Okay. So now we have got the output, right? So now we need to eliminate the like productions which doesn't have the production over there. So we need to eliminate the grammar which doesn't have the production over there. Okay. So in the bottom of the slide, I have given the list of like probability we have initially taken, and we need to check whether all these have some production over there. So here you can see, let me like tick one by one. So Q1X, Q1 1X, so Q1 1X where I have, oh sorry, it's here it is Q1X Q1. So sorry so guys, Q1X Q1. So Q1X Q1 has a production. Then Q0X Q1. So Q0X Q1 has a production. Then Q1X Q1 again the same one. Then Q1 Z0 Q1. So here we have the production. So we have these production now. So next I think this tick will not be there. So the second one, okay, I should remember. So there is this one Q1X and this one. So these production we already have, right? So similarly Q0 Z0 Q0, Q0 Z0 Q0, here we have Q0 Z0 Q1, here we have Q0X Q0, Q0X Q0, here we have Q0X Q1, Q0X Q1 already I have ticked it. Fine. So this is a list of production we have. So it means that this particular probability we have written and this particular probability we have written doesn't have a production. So obviously as per our rule, if a grammar doesn't have a production, that it is a useless symbol. So wherever you are seeing this symbol, so this symbol you need to cut here, it have to cut here. And similar way, as it was not in the LHS, if it is there in the right hand side also, we can't substitute anything, right? So find where this Q1 Z0 Q1 is available over here. Here it is available. So the entire production you can cut it out. Similarly here also Q1 X Q0 is there. We doesn't have any production to go on, so cut it out over there. So here we are simplifying the grammar. So finally, please write the answer. If you are not writing the answer, then obviously you won't be getting your full marks. So finally you write what is your start symbol and what are all your final grammar over there. So that will give you the full mark. Hope this was a short video of the conversion of your PDA